Before we jump into the technicalities, let me briefly explain what we're going to achieve today. You see my notes to the left, and in general, this is going to be a step-by-step guide for how to expand your Kubernetes Home Lab cluster. The things that we're going to achieve are the following. We're going to make the Raspberry Pi that we've previously set up as a Kubernetes cluster a dedicated control plane for the cluster. We're going to be adding an old laptop that I have flying around at home and which has absolutely no use right now as an extra node to the cluster. We're going to install Longhorn, which is a distributed storage solution for Kubernetes, and we're going to use the hard drive of the laptop as a persistent storage. We're going to be setting up Prometheus and Grafana for monitoring of the cluster. Given the fact that we're going to have 2 nodes, we need somehow to observe how much memory, for example, they are using, and if there are any bottlenecks or any issues with the cluster. And lastly, we're going to install Lens, which is an IDE for Kubernetes, and this is going to allow us to navigate a little bit easier the cluster. Before we start with the actual configuration, make sure to install Ubuntu on your laptop or your extra node machine. Just navigate to ubuntu.com, click on products, go to server. Here you can get the Ubuntu server by clicking on download. I'm not going to go so much into detail how to install Ubuntu. There are numerous tutorials out there, so just simple Google search will help you find the proper way to do it. Just in general, there are Rufus and Balena Etcher for creation of bootable USB media, and again, please follow an online tutorial to find how to install Ubuntu. After you install it, we need to update the system. So here to the right in the upper terminal, I'm already connected to my worker node. So this is the laptop running Ubuntu, and below is my Raspberry Pi. That's going to be our control plane. I'm just going to update the packages. So while this is being done, let's continue with the Raspberry Pi. We want to add a taint to the node so that no pods are scheduled on it. So for this, I'm just going to copy this command. I'm going to paste it below. And here we must give the Pi node name, which is for me simply Pi. And then this is the taint that we're going to add, which again just makes it not schedulable. So let's add it. I've actually already did it. So this is why we get this error message that our node Pi has this taint already added. And if we describe the node, you're going to see that there is a taint already added and the pod is not schedulable. So our system is updated on the laptop running Ubuntu, and we have the Pi node already marked as non-schedulable. So the next step is to connect our new node to the cluster using K8s in agent mode. We're going to need the IP of the control plane of the cluster. For this, I'm going to run ifconfig on the Raspberry Pi. And we're going to scroll up, and this is my control plane IP. What I'm going to do is I'm just simply going to copy the command below. This is the command that's going to install our K8s agent. Let's paste it on the node that's going to be added to the cluster. And here under control plane IP, we must define the IP that we're seeing. And what we need as an extra thing is the K8s token. So for this, we need to extract it using this command. We're just going to copy it, navigate back to the SSH on Raspberry Pi, clear the terminal, and simply execute the command. And I'm going to copy the token, paste it in the above terminal, and start the installation process. And if you don't see any errors, K8s was capable of installing the agent on the new node. So if we describe the nodes with kubectl get nodes, we're going to see that we have 2 nodes now. We have the Pi node, which is our control plane master, and we have the node 1, which actually has 3 days of age because I've already set it up previously. And now we have the new node connected to the cluster. We can schedule pods on it, but before doing this, we want to use the hard drive on the laptop so that we have persistent storage. How to install Longhorn, you can find on the page of Longhorn. I'm just going to scroll up. You can see that's the official web page. If we click on it, you can go on docs, use the latest docs, of course. And then there are different options to install it. I'm going to use the kubectl option. I've already copied those 2 commands in my guidelines. So let's go back. And there's one extra thing that we need to do prior to installing any Helm packages or predefined YAMLs. We want to replace the kubeconfig that's used by kubectl by the kubeconfig that's generated by K8s. And there are slight differences sometimes, so this is an extra step that's ensuring that kubectl and Helm is going to work without any issue. So simply copy this command and paste it below. This is going to copy the kubectl from this directory to our, let's say, official kubectl directory. Then we continue with installing Longhorn. we're just gonna copy the command. That's a predefined YAML here. That's gonna install a couple of services. So as you can see, it's starting to create stuff, and we can watch how the process is proceeding. We have to wait till the whole thing is set up and all of the needed resources are up and running. So this takes a couple of minutes here. Longhorn resources are still getting provisioned. So let's just exit this watch command and let's proceed with the next step, which is the monitoring of the cluster. For this, we're going to set up Prometheus and Grafana. Prometheus is a monitoring solution and Grafana is a dashboard solution which can help us visualize the different metrics that we can expose from the cluster. So there is a way to install this using a Helm stack. Helm is the package manager of Kubernetes. If you still don't have it on your system, you can navigate to helm.sh/docs/intro/install and follow the installation process here. I'm just gonna skip this part because I already have it, and I'm gonna add this repo. There is the Prometheus stack, which comes with Prometheus, Grafana, the metrics server, and a couple more resources. I'm gonna add the repository. It already exists because I've done it previously. This is how you're gonna do it for the first time. You're gonna update after adding the repository. Then Helm is gonna check for any updates, update the package repositories, and then we can install the package. This again can take a couple of minutes. So here you must be patient and wait for it to all finish. And of course, while we are waiting, we can do something else. We can install Lens on our laptop, which is the IDE for Kubernetes. I'm gonna just show to you how it looks. I'm gonna go to Lens's page, and this is how it looks. It's very, very awesome. And it's also extremely helpful once you start working with it. So for this, I'm just gonna click on download, then click on download Lens, select my operation system. I'm running on macOS Apple Silicon, so click on download, wait for it to download, and then we can proceed with the install. For me, it's as simple as dragging and dropping Lens in our applications folder. But before we can set it up so that we can connect to the cluster, there is one extra thing that must be done, and I'm gonna show you what it actually is. For this, we wait till our Helm finish installation, and we're gonna proceed with allowing external access to the cluster. So the certificates that are right now generated, they don't allow access via hostname, and we want to externally access the Raspberry Pi control plane using Lens via the Raspberry Pi hostname, which in my case is Pi local. For this, we need to add the Pi local to the TLS certificates, and this requires us to stop the K8s server. Then we are gonna backup and delete all of the certificates. And finally, we are gonna add an extra configuration here under etc/rancher/k3s/config YAML. This could exist, or you might be required to create it. So let's nano this file. And as you can see, for me, it's actually already set up. I've done this previously, but what you need to do is add TLS SAN, and then here under Pi local, you need to add your control plane hostname. So after this is done, we can start the K8s server again. This is gonna recreate the certificates, and it's gonna make sure that all of those new configurations are also reflected. And after this is done, we can run the following command to check if Pi hostname is contained in the certificates. So running it gives us permissions denied. Yeah, this is because we need to run it as sudo. And running it again, actually I'm gonna grep the pi.local. We can see that there is a DNS entry for Pi local in the certificate, meaning that right now we're gonna have no issues with connecting to the cluster. That being done, we can proceed with the actual connection. We have Lens already installed, so what we still need to do is we need to copy the kubeconfig file. So this is where we previously pasted it under .kube/config. So let's cat the file. This is the content here. Let's copy it, and then after copying it, I'm just gonna open Lens. So here I'm already logged in because I've used it previously, but for you, this is going to be the first time. Make sure to use the free plan for your home setup. Of course, if you're running anything in professional manner, please subscribe to the tool. But for us right now, the free plan is enough just to see how it works. So here under Kubernetes clusters, you're going to see that we have local configurations, which is still an empty tab. What we're going to do is we're going to add a new kubeconfig from paste because we have already copied it. And here I'm gonna paste with the difference that we still need to update the server address. So let's just do this. I'm gonna delete the local IP and I'm gonna write pi.local. I'm gonna click on add cluster, which is gonna take some time. And then if I double click here on default, you can see the green status, meaning that we're connected. If I click on overview, our metrics are also here. This is thanks to Prometheus. So you can see we have 31 pods, we have a capacity of 110. And if we check out the nodes, you can see we have node 1 and the Pi node. What I wanted to show you right now is actually the Longhorn UI. So let's go to workloads. Let's check out the deployments that we have already running. I have 2 other deployments, as you can already see, the Quadrant and N88 from the previous tutorials. But if I go to Longhorn namespace, you can see that there are a couple of other deployments, and one of them is the Longhorn UI. And there should be actually a service for the Longhorn UI. So let's check out the services. This is going to be under network services. Here, of course, you see Longhorn frontend. It's running on port 80, but it's not exposed as load balancer service. It's still exposed as cluster IP. For security reasons, let's leave it like this. I'm just going to port forward via SSH port 80 to a random port on my machine. This works by clicking on forward, then leaving here random for the local port, clicking on start, and this is going to open our browser. And here it is. If we go to node, here we can see the node description. So the name, as expected, is node 1. And if we click on edit node and disks, you can see options for selecting the location where our persistent storage is located. So for this, what I want to do is I want to create a new folder, node 1 storage. And then what I'm going to do is I'm going to add a new disk. I'm going to add this location. I'm going to change the name. I'm going to say that I want 120 gigabytes reserved, enable scheduling so that we can disable it here, and delete this one. And yeah, that's it. I'm gonna click save. So now we have to wait until the storage is provisioned. Once this is done, you're gonna see that it's green again. And if we go to the dashboard, we're gonna see that we have 120 gigabytes reserved, 50 gigabytes schedulable, 18 gigabytes used. So we are preparing our system to use as much memory as possible when needed. And that's it. Now we have expanded our Kubernetes cluster with 1 extra node. We can observe it using Lens. And here also we have some metrics that show us how the node is performing. What I still want to show you as an extra example is how to deploy a new pod that is using this storage that we added. I'm going to go back to my guide. Here under the test persistent storage, you can see I have already a predefined YAML file. You can see that I'm defining a persistent volume claim that's using the Longhorn storage class, and it's requesting 1 gigabyte of storage. I'm using this name to assign it to the pod that's deploying Nginx. What we're going to do is we're going to copy. I'm going to clear out the configuration here, and I'm gonna nano a pvc test.yaml file, save it, and then run kubectl apply-f pvc test YAML. So this is gonna create the persistent volume claim and also the Nginx. Let's check it out in Lens. If we go to pods, we just need to change to the default namespace because this is where we deployed it. We see that it's still being provisioned. Let's check out how it's performing. If we scroll down, we're going to see that there were some issues with the persistent volume claim, which have to be tackled automatically. But after some time, the cluster is capable of accepting this persistent volume claim and the pod is getting started. So the pod is running. If we check out the logs here, you just click on logs, you're going to see that it's running. To try out how the storage works, we can try writing a file to the storage, running this command, which is going to execute a echo command in the test pod. And after that's done, we can check out if there's a file there. So it actually created a file under data called test.txt. And if we cut the file, we can see that it's there. If we decide to delete the pod for some reason, so let's just remove it. It's already gone, it's not there. And later on, we decide that we actually still need the data and we still need to run the pod. If we execute only this part of the code, so I'm just gonna create a new file called pod test. I'm gonna paste the config here, save the file, and then kubectl apply-f. We're gonna see that the pod is created. And what we're gonna do right now is we're gonna try to cut the same file in this new pod, which if it's not using the persistent volume, it's not gonna have file inside. Let's check it out. And of course it works because we're using a persistent volume that was deployed using Longhorn separate to the pod. And in addition to this, it's going to allow us to have pods distributed across multiple nodes, but still access the same type of data. And that's it. It might look simple, but today we actually achieved multiple things. We expanded our cluster in a way which allows us to add even more nodes. In addition to this, we installed the Prometheus stack, which includes Grafana and metric server. So if you play a little bit with it, if you check out what exactly it's deployed, which resources exist, you can see that there's a lot more to it. We've also added Lens, which allows us to play with the cluster in a faster visual manner. We can also observe how the cluster is performing using the metrics from Prometheus. So thanks to it, we have this nice overview here. And lastly, we have provisioned a distributed persistent storage. That's a very big step in your Kubernetes journey. So I congratulate you for coming so far. If you enjoy it, please like the video, subscribe to the channel, and ring the notification bell. If you have any comments or any remarks, please drop them in the comments below, and I'll see you in the next one.